Hello everyone, today is day 63 of solving a LeetCode problem every day, and today I'm going to be solving subtree of another tree. If you hear any background noises, I'm sorry, I just got a brand new puppy, yeah. So given the roots of two binary trees, root and subroot, return true if there's a subtree of root with the same structure and node values of subroot, and false otherwise. So all this is saying is we're going to be given two trees. One's going to have the root and the other one's going to have the root subroot. We want to return true if there's a subtree of root with the same structure and node values of subroot. So a subtree of a binary tree is a tree that consists of a node in tree and all of this node's descendants. So for example, in this case, we can see that subroot is a subtree of root because we have both these fours in both trees and their children's match up, which means that this is a subtree of this tree. The tree could also be considered a subtree of itself. So if we had root and then another, if subroot was just equal to root, subroot would be a subtree of root. And one thing I want to mention is that if subroot was null, it would also be a subtree of root. So we went over this. This is going to be true. In this case, it's going to be false. So you might see we have the 412 here, the 412 here too, but then we have this left child, which is a 0, which is why it's a false. We need this 0 here on the left child of 2 for the output to be true. So there's two ways of doing this that I know of. The way I'm going to do it today is using depth first search, just because I'm more focused on practicing my tree traversals. So what we're essentially going to do is iterate through every node in here and then check if this tree is equal to this tree. So we're going to start at the root, check if this whole tree is equal to this whole tree. It's not. So now we go to this left child. We check if this subtree is equal to this tree. They are. So in that case, we can return true. So that's the general idea. So I'm going to first define that is same method to check if the trees are the same. And all we have to say is, or not all we have to say, but this is going to take self, root, and subroot. And what's going to happen is each time we're going to return. So first of all, we have to check, or let me do this first. What we're going to do is self is same root dot left alongside subroot dot left, and self dot is same root dot right alongside subroot dot right. Oops, subroot dot right. So now if I go over here, I feel like I am missing something. Right, so we're saying self, so we want to make sure that both of these are true. Okay, what we actually want to do is put this in an if statement. So if root is equal to subroot and the values are the same specifically, then we want to return this. Otherwise we can just return false. And then we have our base case. So if not root and not subroot, we can just return true. Cool. So now we want to do the is subtree method. So this is what we are going to do. So again, we want to iterate through all the nodes and we want to check if they're the same. So we're going to say self dot is same root alongside subroot. Now we check if these are equal. And we're going to put this in an if statement. And if they are equal, we can just return true. Otherwise, what we want to do is call this is subtree method again. And what we're going to do is pass in the root dot left with the subroot, or self dot is subtree root dot right with the subroot. So this is what we're going to return. And so the reason we're saying or is pretty much what we're saying now is if the left subtree is the same tree as a subroot tree, or the right subtree is the same as a subroot tree, then in that case, we can return true. So now we're going to do one more thing. So if the subtree is empty, or if the subroot is empty, we can just return true at this point, since it's always going to be a subtree of root. However, if root is empty, I put that in the wrong place. So if subroot is empty, we can just return true. But then after this, we're going to check if root is empty. In this case, we can return false. And the reason why is because if subroot, here we basically checked, if we get to this step right here, then we know that subroot has some value. So if subroot has some value, but root has no value, then subroot can't be a subtree of root, which is why it works that way. So if I run this, let's see. Oh, so what I forgot here is we also have to check if root and subroot actually have values. Okay. So now if I run that again, it's accepted, and I submit it, it also got accepted. So cool. So as for space complexity, this is going to be a recursive method. So it's going to take up constant space, but the amount of space that's going to be taken up on the call stack just depends on how large the root tree is and the subroot tree is. But then the time complexity of this is going to be O of n times m, we can say, where n is the size of the root tree and m is the size of the subroot tree. And the reason why I say that is for each node, we have to make m comparisons. So when we go to 3, at most, we can only do these 3 comparisons right here. And then we go to each node, which is why it's O of n times m. So yeah, that's my solution for the day.